NEC 250.104b addresses the bonding of metal water piping. The crucial part of this section states that the bonding jumper shall be connected to the water pipe at least 4 feet from the water heater or other sources of heat, if such a connection is practical. Note that the code does not specify a minimum size for the water line itself when it comes to bonding. The primary concern is establishing a reliable electrical connection to the metal water piping system to ensure electrical safety. You must bond to a cold water pipe. Your superior might be confusing bonding jumper requirements with grounding electrode conductor requirements. The NEC 250.52 ATWO does address the size of the metallic water pipe when used as a grounding electrode. It mandates that when using a metallic water pipe as a grounding electrode, it must be a minimum of 3/4 of an inch in diameter. This requirement applies specifically to a water pipe when it serves as a grounding electrode and not when it is simply being bonded. A bonding jumper serves a different purpose than a grounding electrode conductor. A bonding jumper ensures electrical continuity and reduces the risk of electrical shock by connecting metallic parts to the electrical system's grounding system. It helps to equalize the electrical potential between different metal parts, minimizing the voltage difference that could cause a shock. A grounding electrode conductor, on the other hand, connects the electrical system to the earth, providing a path for fault current to flow back to the source and trip a circuit breaker or fuse. In your specific situation, bonding to a 1/2 inch water line is acceptable as long as you adhere to all other requirements outlined in NEC 250.104b. The key is to ensure a solid and reliable connection and that the bonding jumper is appropriately sized for the circuit it serves. Firstly, ensure the bonding jumper is sized according to NEC 250.102c, which dictates the size of the bonding jumper based on the size of the ungrounded conductors supplying the circuit. Secondly, the connection point and the water pipe must be clean and free from corrosion to ensure a good electrical connection. Thirdly, the bonding clamp used must be listed for the purpose and compatible with both the water pipe material and the bonding jumper conductor. Fourthly, the bonding jumper should be installed in a manner that protects it from physical damage. Fifthly, the length of the bonding jumper should be kept as short as possible to minimize impedance. The reason for keeping the bonding jumper at least 4 feet away from the water heater is to prevent the heat from the water heater from affecting the bonding connection and to ensure that the bonding is effective for the entire water piping system. If the connection is too close to the water heater, the heat could potentially degrade the connection over time. Furthermore, it's crucial to understand the definitions and differences between grounding, bonding, and equipotential bonding. Grounding refers to connecting the electrical system to the earth, providing a path for fault current to flow back to the source. Bonding is connecting metallic parts to the electrical system's grounding system to equalize electrical potential. Equipotential bonding is creating a low impedance path between all metal parts in a specific area, such as a swimming pool or bathroom, to minimize voltage differences and reduce the risk of electric shock. When working with electrical systems and the NEC, always consult the latest edition of the code and any applicable local amendments. The NEC is updated regularly to reflect changes in technology and safety practices. It is also essential to understand the specific requirements of your local jurisdiction, as they may have additional rules or interpretations that you must follow. Always consult with a qualified electrical inspector or engineer if you have any questions or concerns about electrical installations or code compliance. They can provide you with the most accurate and up-to-date information based on your specific situation. Remember, electrical safety is paramount, and following the NEC and local codes is crucial for protecting people and property from electrical hazards. When dealing with plastic water lines entering a building, the bonding requirements can differ slightly. Since plastic is a non-conductive material, it cannot be directly bonded. However, if there is a metallic water piping system within the building, it still needs to be bonded to the electrical system's grounding system. In this case, the bonding jumper would be connected to the metallic water piping system as close as practical to the point where the water surface enters the building. The purpose of this bonding is to ensure that any stray voltage that may be present in the metallic water piping system is safely conducted back to the electrical system's grounding system. Additionally, if there are any other metallic components associated with the water system, such as metallic valves or fittings, they should also be bonded to the electrical system's grounding system to ensure equipotential bonding. In situations where there is no metallic water piping system within the building, other grounding electrodes may be required, such as a ground rod or ground plate, to provide a path for fault current to flow back to the source. The specific grounding electrode requirements will depend on the size of the electrical service and the local code requirements. When installing bonding jumpers or grounding electrode conductors, it is essential to use the correct type of connectors and hardware. The connectors must be listed for the purpose and compatible with the materials being connected. For example, when connecting a copper bonding jumper to a steel water pipe, a listed copper to steel connector must be used to prevent corrosion and ensure a reliable electrical connection. It is also essential to follow the manufacturer's instructions for installing the connectors to ensure a proper and secure connection. Over-tightening or under-tightening the connectors can damage the conductors or the connection points, leading to a faulty connection. In addition to the bonding and grounding requirements for water piping systems, the NEC also has specific requirements for bonding and grounding other metallic systems within a building, such as gas piping, HVAC ductwork, and metal building structures. These systems must be bonded to the electrical system's grounding system to prevent voltage differences and reduce the risk of electrical shock. The specific bonding and grounding requirements for these systems will depend on their size, location, and the type of electrical equipment they serve. When working with electrical systems, it is always best to err on the side of caution and consult with a qualified electrical professional if you have any questions or concerns. They can help you ensure that your electrical system is safe, compliant with the NEC and local codes, and properly bonded and grounded to protect people and property from electrical hazards. The NEC is not just a set of rules, it is a comprehensive guide to electrical safety. By understanding and following the NEC, you can help to prevent electrical fires, shocks, and other electrical hazards. Remember, electrical safety is everyone's responsibility, and it is up to each of us to ensure that our electrical systems are safe and properly installed. When considering the practical application of bonding jumpers, remember that the goal is to create a low impedance path for fault current. This low impedance path is critical for the quick operation of overcurrent protective devices, such as circuit breakers or fuses, in the event of a ground fault. If the bonding jumper is too small, poorly connected, or excessively long, it can increase the impedance of the fault current path, slowing down the response time of the overcurrent protective device and increasing the risk of electrical shock or fire. Therefore, it is essential to carefully select and install bonding jumpers according to the NEC requirements and best practices. In addition to the size and material of the bonding jumper, the method of attachment is also crucial. The bonding jumper must be securely and reliably connected to both the metallic water pipe and the electrical system's grounding system. A connection point must be clean and free from corrosion, and the connectors must be listed for the purpose and properly installed. Avoid using makeshift or unapproved methods of attachment, as these can compromise the integrity of the bonding connection and increase the risk of electrical hazards. Regularly inspect bonding jumpers and grounding connections to ensure that they are in good condition and properly connected. Look for signs of corrosion, damage, or loose connections. If any issues are found, they should be promptly addressed by a qualified electrician. Neglecting maintenance can lead to a deterioration of the bonding and grounding system, increasing the risk of electrical hazards. When making any changes or additions to an electrical system, it is essential to re-evaluate the bonding and grounding system to ensure that it is still adequate for the new load. Adding new circuits or equipment can increase the potential fault current, requiring larger bonding jumpers or additional grounding electrodes. Always consult with a qualified electrician to determine the appropriate bonding and grounding requirements for any electrical modifications. Furthermore, consider the impact of future changes to the building or the electrical system. For example, if there are plans to replace the metallic water pipe with a non-metallic pipe in the future, the bonding and grounding system will need to be modified to ensure continued electrical safety. Planning ahead can help to avoid costly and time-consuming retrofits. Ultimately, the effectiveness of a bonding and grounding system depends on its design, installation, and maintenance. A well-designed and properly installed bonding and grounding system can provide a high level of protection against electrical hazards. However, a poorly designed or improperly installed system can be ineffective or even create new hazards. Therefore, it is essential to rely on qualified electrical professionals for all bonding and grounding work. They have the knowledge, skills, and experience to ensure that your electrical system is safe, compliant, and properly protected. They can also help you to understand the NEC requirements and make informed decisions about your electrical system. In addition to the technical aspects of bonding and grounding, it is also important to consider the human factor. Electrical safety training is essential for all workers who may come into contact with electrical systems. Training should cover topics such as the hazards of electricity, the proper use of personal protective equipment, and the procedures for working safely around energized equipment. By promoting a culture of safety, you can help to prevent electrical accidents and injuries. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always take the necessary precautions and follow the NEC and local codes to ensure electrical safety. Electrical safety is not just a matter of compliance, it is a matter of life and death. By prioritizing electrical safety, you can protect yourself, your family, and your community from electrical hazards.